Quadratic equations, quadratic functions, things like that. We're going to start off by learning how to graph quadratic functions in what is called vertex form. Alright, and to help us today we have Bean Skywalker, that's right. Mr. Bean, a longtime Jedi, and I have the footage of him training when he was just a little kid himself. Watch this.
It seems that as a 13-year-old, George Michael had been heavily influenced by the Star Wars films and had endeavored to recreate his favorite moments.
I spent $2.1 million of good company money and end up with this?
You cut off my hand!
Worth every penny.
What can I say? Bean Skywalker's got moves, alright? So here we go, quadratic function. Y equals a times x minus h squared plus k is a vertex form. A cannot equal 0 because if it's 0, that's all gone. Alright, but we're going to have numbers for a, h, and k. The x and the y, of course, are going to stay like always. The graph of any quadratic is a parabola. It's a U shape. It's curved, not straight. You can see down here we have a quadratic. We have the parent function, which is x squared. Remember, this is the basic function. This is the beginning, the building blocks of the quadratic. All right, you can see it's U-shaped. In other words, I come down here, I didn't make a straight line. All right? Now, I apologize. You all know I'm not the best at drawing lines. So you think I'm very good at drawing curves? Probably not, they say. Probably not, and that's the truth. So let's talk about this. We have a couple of cool things about quadratic functions. We have a vertex, and the vertex is the lowest or highest point on the parabola. It's the minimum or maximum. As you can see, this U, it comes down and then it goes back up. It never goes below here. This point right here is the vertex. It is the lowest point. In this case, it's a minimum. All right, it's a minimum point. We have an axis of symmetry, and it divides the parabola into mirror images. It passes through the vertex. So this equation, x equals 0 for this one, it folds over and actually is a mirror image on both sides. The great thing about that is this. If I were finding a table, if I found this point, I don't need to find this point. I know that it's 1 over here, boom. All right? Same thing, when I found this point, I go 2 over and put the point here, 2 over. When I find this point, 1, 2, 3 to the line, 1, 2, 3 to the line. You'll remember in geometry we did some stuff with translations and transformations and things like that. It's going to come in handy today. All right? So let's take a look more in depth about this. Some properties of quadratics in vertex form. And remember, y equals a times x minus h squared plus k. Let's see. The vertex is... All right, let's go take a look around here for a sec. Here we have the parent function, all right? This orange curve here, this orange parabola, is always y equals x squared, all right? What I've done here is now I can move some things around. So the first thing I move around is this h. What happens when I make, even though it says minus h, minus you think what? Probably down or left. Right? These are the things that we think about since minus. So if I put a number in there, let's say I move it up to, oh, and you can see right now, as I make it positive, it actually does the opposite of what I would think. So instead of moving it to the left, it's moving it to the right. Let's see. If I move it to the left, I go to negative numbers, right? That moves to the left. But a negative of a negative, it would really be a positive in here. It's kind of counterintuitive, all right? Let's see what we have with k. What does the k do? When I slide the k positive, it goes straight up. You see, I'm just translating that function. I'm just moving the function straight up. Nothing has changed about that parabola except for where the vertex is. Right now, the vertex, instead of being at 0, 0, is at 0, 2. All right? I can make it higher. I can make it go lower. All right? So right now we know that if I move the h, it moves the vertex left and right. All right? If I change the k, it moves the vertex up and down. And k up and down is y coordinate, and h, left and right, is going to be an x coordinate. So let's write that down real quick. All right. So the vertex is h comma k. All right. Now the trick here is this. Let's say I have y equals 2 times x plus 3 squared plus 2. Because this is a minus, I have to take that into account. It's the opposite of what I see. So the opposite of 3 is negative 3, and k is the same 2. All right? If I had y equals negative x minus 2 squared minus 2, I see minus, well, that's what it is, but I'm plugging in a minus here, so it's the opposite of that, which is positive 2, negative 2. All right, let's see if we can find out what the axis of symmetry is on our graph. So we come over here. Remember, right now we have this vertical line right now splits our parent function in equal parts. So it's reflected across that. That's our axis of symmetry. And remember, when we have vertical lines, that's x is always 0 here. All right? So let's move our graph a little bit. Let's say that our h is 3 and our k is 2. All right? So now we need to move our axis of symmetry. All right. Let's move our axis of symmetry until it gets right there, right? That looks like now the axis of symmetry for this one. So let's see, what is our value here? What is our x equals number? X is going to equal 3. Let's see, 2, 3. Yep. So in this situation, x equals 3 is our vertical line that cuts it in half. All right? The great thing here is that our axis of symmetry is always a line, and it's always going to be whatever our h value is. If I made h negative 4, then I would have to make our axis of symmetry negative 4 to match it. Okay? So let's write that down. So our axis of symmetry, remember, is a vertical line, and vertical lines are always x equals. In this case, x equals h. So for this top one, the first one, our axis of symmetry would be x equals, all right, now be careful, it's a negative here, opposite, so negative 3. In the second example, opposite of 2 is, or opposite of negative 2 is 2, so x would equal 2. All right, let's check this out. Now this one is talking about the a value, that a value in front. What does it do to the graph? What if it's greater than 0? What if it's less than 0? All right, let's go to the thing. Let's see. Greater than 0, less than 0. Let's reset this. So we have our parent function again. All right. All right, so we have our parent function. Let's just deal with a. As let's see, I want positive. Right now I have a positive, and it goes up, right? What happens if I make that a negative? Less than 1. Less than 1, it opens down. Let's see, is that true for all negative values? Yeah, it looks like all negative values are going to be upside down. Oh, let's go positive. Positive values are going to be opening up. Negative values are going to open down. Let's write that down. All right? So we have, if a is greater than 0, the parabola opens up. And if a is less than 0, if a is negative, right, then the parabola opens down. All right. Now we have a tricky one. It says if the absolute value of a is greater than 1, or if the absolute value of a is less than 1. Basically what this is talking about is this. If I have numbers between negative 1, and 1. So like 0.05 or negative 0.9. Things like that. All right, what's happening? Okay, let's take a look at our parent function. Let's start this over again. So this is 1. All right, so let's make a bigger than 1. What is happening to the shape of our parabola when a is bigger than 1? As I make it bigger than 1, what is happening? It gets closer and closer and closer and closer to that axis of symmetry, right? In other words, you could say it's getting narrower. It's getting narrower, all right? It's getting narrower. So when I get back to 1, boom, okay? Now let's look between 0 and 1. So all these other numbers, 0 and 1. Oh, it's getting bigger. The closer it gets to 0, in fact, let's get real close to 0, 0, 0, 5. Whoa, look at that. It's way wider, right? So the closer it is to 0, the wider it's going to be. The closer it is to 1, the closer it's going to look just like a normal parabola. All right, and the same thing's true if it's upside down. If I have a negative, if it's less than 1, boom. Once it gets above the absolute value of 1, it gets narrow. All right, let's write that down. So, if the absolute value of a is greater than 1, it is wider than y equals x squared, right? Wrong. It's thinner, narrower, okay? It's narrower. See, it's kind of counterintuitive. You'd think as it gets bigger, it would open up much bigger, but it's not. As it gets bigger, it actually gets narrower. When the absolute value is less than 1, that's when it is wider than the parent function of y equals 1. All right, I hope that makes sense. All right, so let's graph one right here. Y equals quantity x plus 3 squared minus 4. So remember, what's our vertex? Our vertex is hk, and h is here and k is here. And so it's the opposite of plus 3, it's negative 3. And the opposite, or nope, we keep k is going to be negative 4. So the first thing I want to find is the vertex. Plot that point. 1, 2, 3, 1, 2, 3, 4. All right? What's the next thing I need? I need that axis of symmetry. And remember, the axis of symmetry is x equals h. So what is our equation here? X equals negative 3. All right? And the nice thing is, once I have my vertex, it's really easy to find. I'm going to draw my line just like this. I'm going to label it because on the homework and the master check is going to ask for you to label it. So x equals negative 3. All right, now how do we find the rest of these? Well, here's the best thing to do. We need as many points as we can. Go 1 over. Either way, it doesn't make a difference. All right, so I'm going to go over here. That's negative 2. All right, how can I find anything? When I have a table, I can take my x value and plug it in and get my y, or my f of x. So negative 2 plus 3 squared minus 4, right? So negative 2 plus 3 is 1. 1 squared is 1. 1 minus 4 is negative 3. So I'd have negative 2 and negative 1, 2, 3. And the great thing is, we already know that there's a point right here because this axis of symmetry, it's reflected across. So we reflect it right here, boom. Now, I can do this, and it's real easy. All right, another trick you could use, and if you remember how to use your table and your graph and your graphing calculator, it makes life real easy as well. Put in our equation, x plus 3 squared minus 4. And we want our table. So I'm going to do second table. All right, and let's see. We had negative 2. We should probably do negative 1. So I'm going to scroll up to negative 1, and my value is 0. And then we'll do one more. So I had negative 2, negative 1. Let's do 0. So then 0 would be 5. So I'm going to have 0 and 5 as my next 2. So negative 1 is 0, and 0 is 5. Let's take a look here. So negative 1 is 0. And then I can reflect that. 1, 2, 1, 2. And then 0 is 5. 1, 2, 3, 4, 5. You can see the cool thing about parabolas, that squared, as you keep going, as you get further away from the vertex, it goes up much faster. 1, 2, 3, 1, 2, 3 over here. All right, now the trick is to curve this, right? Try to curve it as best we can. Mr. Bean really wants to make sure you understand that is a curve and not a straight angle there, all right? All right, so there you have your vertex, form, graphed. Let's try another one. All right, negative 2 times x minus 4 squared plus 8. So let's get our vertex. We know it's the opposite of this, so it's positive 4, 8. Positive 4, 8. 1, 2, 3, 4, and up 8. Right here. Now I know I didn't give you two graphs. I assume you're big kids. You can, graph it on the same one, save some trees. Especially all those kids out there, I know you always harass me about killing trees. So we know our axis of symmetry is the x value, 4. All right, probably should label this vertex, right? 4 and 8. All right, so we need some points. I'm going to put it in the calculator just because I think that's a little bit faster. All right, so I'm going to clear that. Negative 2. Oh, it's a negative. That means it's going to open which way? Up or down? Yep, it's going to open down. All right, got that. Go into our table of values. All right, now we are at 4. So I'm going to do 3, 2, and 1. So 3, 2, and 1. Let's see. So at 3, it's 6. Whoa! That jumped real quick, didn't it? Going back. Here's a good trick. Table set. You can change where you start. It goes right to it. So 3 is at 6. Then 2 is going to be at 0. And 1 is going to be at negative 10. All right, so 6, 0, negative 10. So 3, 6, 2, 0, 1, negative 10. So 3, 6, 1, 2, 3, 4, 5, 6, 2, 0, and then 1, negative 10. Ooh, that just fits. Now here's a great point. Sometimes you're not going to be able to fit all these points. Reflect it. What you need to do is you need to fit as many as you can. Sometimes you're going to get 5, right? Sometimes you're going to get 7. You need to get as many as you can. 3 is about the minimum, but 5 is really what we're looking for, all right? So I need to make sure I curve this so Mr. Bean doesn't get mad. And then, whoa. And I remember it's narrow because my A value is greater than the absolute value of 1. All right? All right, now, I've shown you the long way. Let's take it and look at an easy way. All right, this is called the 1-3-5 shortcut. And this works for quadratics, okay? And this kind of deals with slope, rate of change, things like that. All right? Let's go all the way back to our first one. All right, look at our table here. Here was our vertex, right? From 0 to 1, that was a change of 1. From 1 to 4 was a change of 3. And from 4 to 9 was a change of 5. 1, 3, 5. And the other way, 1, 3, 5, exactly the same. Let's see another one. All right. We had x plus 3 squared minus 4. All right. So our very first point was negative 3, negative 4. And then it went up 1, up 3, up 5. 1, 3, 5. All right? So our rule is this. The change, the rate of change, so to speak, it goes up 1 over, up 1, then up 3, then up 5. All right? Now this correlates when A is 1. And we'll talk about what happens when A is not 1 in a second. So when A is 1, I'm going to plot my point. Negative 6, 2 is my vertex. 1, 2, 3, 4, 5, 6, and up 2. All right, now this is a negative, so I know that is going to open down. I know that my axis of symmetry is right here at x equals -6. I'm going to do my 1, 3, 5. So I'm going to go over 1. And then my first one is 1, so down 1. Because it's negative, I go down 1. And I go over 1, and my next one is 3. 1, 2, 3. Boom. Then I go over 1, and I go down 5. 1, 2, 3, 4, 5. And of course, I can reflect these across the axis of symmetry. And draw my nice little curve. All right? 1, 3, 5. Piece of cake. That's when A is 1 or -1. Let's take a look. Our last one wasn't 1, was it? So our very first point was 4, 8. So this was 2, 6, 10. 2, 6, 10. All right? Well, 2, 6, 10 is just 1, 3, 5 multiplied by 2. All right? 2 times 1, 2 times 3, 2 times 5. So the rule is, whatever our A is, we can multiply that. All right? So whatever A is, you multiply by 1, 3, 5. Let's do the next one. So on this one, we have to take a look. We have our vertex. It's at +2 and -3. So we come over 1, 2 over, 1, 2, 3 down. All right? So our axis of symmetry this time is going to be at x is 2. Now remember, we have 1, 3, 5. That's our trick. But we're doing it by a half. So a half times 1 is a half. A half of 3 is 3 halves. Also 1.5, 1 1/2. Half of 5 is 5 halves, or 2 1/2. So I always go over 1, and I'm going to go up a half. Over 1, up a half. Over 1, up 1 1/2. So I'm going to go up a half and 1. Over 1, up 2, 1, 2 1/2. We have it right there. I'm going to reflect it across the axis of symmetry. And I'm going to do my best to make sure this is nice and round. Remember, V is our absolute value. And there you have it. You can tell this is a little bit wider than our parent function, and that's because we are multiplying by 1/2 this time. So we're going to multiply everything by 3. So instead of 1, 3, 5, we're going to have 3, 9, 15. What are the chances of this fitting on? All right, well, the first thing I notice is this. This is the same equation. When I don't have -0, I don't write it in there. So my vertex is 0, -8. 1, 2, 3, 4, 5, 6, 7, 8. All right, and it opens up, so I go over 1, up 3. 1, 2, 3. Over 1, up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Is it going to be able to go up 15? No. So let's reflect these across our axis of symmetry, which is, of course, x equals 0. And try and draw this as best we can. Make sure it's curved there at the end. Boom. All right? So that's the 1, 3, 5 trick. Really great trick. All right, so now we're going to talk about minimums and maximums. Tell whether the quadratic has a minimum, a maximum, and then find the value. All right, so let's talk a little bit. This is A. A determines if it opens up or if it opens down, right? If it opens up, we have a minimum. That's our lowest point. It'll keep going high forever. If it opens down, we have a max. So if A is a negative, right, like -1, it's going to be opening down. If A is positive, it opens up and we'll have a min. So A here is positive. So I know I have a minimum value. And my minimum value is not the x-coordinate. I don't care where it lines up. I want to know what is this? How low does that go? Well, what is the y value here? The y value here is 6. So in this one, we have a minimum value of 6. All right, piece of cake. Bean Skywalker started as a pilot and was always kind of cocky. Upon returning from a patrol, he requested a flyby. He gave the tower the equation as a vector for his approach. How close will Bean Skywalker be to the ground on his flyby? Sketch a rough graph. All right, so I'm just going to sketch a graph first. This means it's going to be fairly wider than our normal one, right? And this is our vertex. So let's just say this is about 45. So it would look something like this, right? And of course, what we want to know is the distance from where he is to where the ground is. So that's our y value. What is our y value in this situation? 8.5. So he will be 8.5 feet off the ground. All right? Sometimes where problems aren't that hard. All right, pause the video. You try these. All right, here we go. So I'm going to find the vertex first. So that's a 4, 1, 2, 3, 4, and up 7, 1, 2, 3, 4, 5, 6, 7. So my axis of symmetry here is x equals 4. All right, I have -2, so I know it's going to open down. Instead of 1 through 5, I'm doing 2, 6, 10. So over 1, down 2. Over 1, down 6. And the next one won't fit, so I reflect it. Try to draw my nice pretty parabola. Not awful. Remember, they go on forever. Tell whether the quadratic has min or max, then find that value. So we have a negative, right? That means it opens down. So we're going to have a maximum value. And what is that? Well, that's our y value. That's 52. All right. There you have it. Before I leave you, I'm going to give you some words of wisdom from one of my favorite teachers of all time. And good luck on the metric check. I'll see you on the flip side.
Always with you what cannot be done. Hear you nothing that I say. You must unlearn what you have learned.
All right, I'll give it a try.
No, try not. Do or do not. There is no try.